Ladies and gentlemen, it is my pleasure to present a paper on the development of fingerprint-based smart class attendance monitor for tertiary institutions. At this conference, this all-important conference, 2020 Sustainable Energy, Engineering and Industrial Technology Conference of the Faculty of Engineering, University of Nigeria, Nsukka. I am Reverend Father and therefore the content of our presentation are as follows. As an introduction, we note that a number of studies have been carried out on the relationship between students' class attendance and their performance within and outside school. These findings tend to suggest a reasonable correlation between class attendance and students. In view of this, some universities, especially in Nigeria, stipulated a certain percentage attendance as a condition for eligibility to sit for regular university examinations. Unfortunately, on account of the large number of students, the implementation of this policy is often hindered by cumbersomeness and unreliability associated with manual attendance register. A veritable alternative is automation of class attendance via biometric identification system. A biometric system can be described as a pattern recognition system. A typical biometric system is capable of capturing the biometric data of an individual, extracting from the captured data a set of features that uniquely identifies the individual, and storing the identified template in a database. Common biometric systems are based on facial recognition, facial tomography, fingerprint recognition, hand geometry recognition, ear geometry recognition, iris recognition, retinal recognition, vascular pattern recognition. Um, this work presented an effort at developing an automated class attendance using deep learning framework. It is based on face recognition. Basically, the issues here about getting the face detection network and then getting the face recognition network. Another work was based on wireless, a kind of wireless attendant based on iris recognition, where the basic biometric data of interest is in the here there is an iris scan, and then it extracts basic features in the eye and is able to match the process, and will continue. For all this, however, fingerprint-based biometric systems stand out on account of the maturity and availability of associated technologies. Our work will therefore be based on fingerprint. Basically, in a fingerprint attendance scheme, you have the user and the device interface, you have class attendance, you have fingerprint enrollment, you have fingerprint processing, you have verification, and then you have generation of data. There are other works that have been carried on in this area of biometric, fingerprint-based biometric recognition, facial recognition, but we are not going to bother ourselves with present because they will be there in the paper that. But essentially, we note that the materials we are going to use will, in a fingerprint sensor commonly, there is a fingerprint sensor that is the primary thing that is used in the fingerprint-based attendance scheme. There are two types. You have the optical type and the capacitive type. We will use the optical type because it tends to have more reliability. When it comes to the proposed architecture, there are three levels of architecture, three levels of involvement: perception layer, network layer, and application layer. This is our perception layer concerned with tracking and identification of the objects. When it comes to the network layer, we have a number of options to choose from. We have the Wi-Fi option, we have the Zigbee option, we have the MQTT option, and we have the LoRa option. On account of unavailability of Wi-Fi and of course the cost in terms of energy and everything, we intend to use the LoRa. The LoRa is a long-range wireless area network that is recently introduced, and it has capacity for low power, and it can be used with, it belongs to a free, the layer is free, the spectrum is free, and so it has its advantages, especially in view of increasing the security of the work through multi-level um, saving of data, because we need the network layer in order that the data that is produced at the local device level will be immediately transmitted via the network layer to a server. At the application layer, you have some functions like data encryption, scheduling events, modes update, and stuffs like that. And here we choose the TeamSpeak for implementation layer. This is a pictorial diagram of our entire system. You have the local device, you have the gateway, you have the security check, you have the storage, and then there's an admin that is actually administering the in terms of operation, the system will start, and there will be three levels, three possibilities: either that enrollment is being done, either that attendance is being done, or that data is being deleted. Enrollment will require passwords, but that attendance will not require passwords. Um, Deletion of data will also require back password. So when enrollment is undertaken, it will be stored in the fingerprint module. When attendance is undertaken, it will be stored in the flash memory of the microcontroller. It will also be stored inside the SD and inside a server, local server, and then finally uh, a central server that will take care of everything in order to improve the security and integrity of the. In conclusion, it is our thinking that a smart class attendance register will be very important and will be quite efficient, and will instill a sense of seriousness and control on staff and students who will be encouraged to dutifully follow university timetable. The end result, we hope, is improved service delivery. Thank you for listening.